Abstract.
Practice different agarose gel concentrations were made at 0.8%, 1.6%, and 2.5%, adding red in order to realize an electrophoresis for different samples. 100 BP ladder, fast DNA ladder, 2-log ladder, plasmid E. coli genomic DNA, Laquache RNA, and PCR product. Mixed them with loading buffer. Pipette and skills agarose concentration, electric charge, and loading buffer will be determined to analyze the results of each sample after electrophoresis.
Introduction. With the electrophoresis, we can separate DNA strands, allowing us to identify all their components. The technique has several applications, for example, paternity test, comparing the bleed pattern against the marker from dad or mom DNA. This technique also helps us in forensic medicine, identifying certain genetic diseases such as Huntington's and to differentiate between similar animal species. We need to take in account many variables in electrophoresis. Agarose concentration. Depending on the sample, it needs to be analyzed the specific separation ranges for the agarose in the laboratory. The separation of samples is inversely proportional to the concentration of agarose. The lower concentration of agarose, the greater separation, and the higher concentration of agarose, the less separation. Electrophoretic buffer system. The effective separation depends on the effective maintenance of the pH inside the matrix. Therefore, the mobility of the DNA is affected by the composition and the strength of the buffer. Loading buffer. This contains glycerol or sucrose to increase the density of the DNA solutions. Otherwise, the samples would dissolve in electrophoresis chamber. Similarly, it contains dyes that facilitate the observation of the samples in the hell. Voltage or current. It has been established that at higher voltage or current, the DNA will migrate much faster. If this is too high, the bands can be distorted for DNA less than 12 kilobase. In addition, an increase in temperature is caused, which causes the melting of the gel, the decrease in the resolution of the DNA bands, and the explosion of the fuse. Correct voltage 5 volts per centimeter of electrophoretic chamber. Comparing to DNA, in the analysis of RNA, we need to take in account that before we run the sample into gel, we have to make the denaturation before and during the test to avoid secondary structures that affect the result. Lipoxyl DMSO is used for this, but we need to work with caution because this substance is very toxic. Sometimes we want to separate large DNA fragments, so we need to use a different electrophoresis technique that calls electrophoresis of pulsating fields. This consists in creating periodic changes in the electric field, longer duration in the electric field, larger size of the fragments that separates. Table 2. Electrophoresis considerations for DNA, RNA, and proteins. The composition of the matrix used in DNA PMOL 28 and Canis lupus RNA is agarose. It is the most commonly used method for the size and shape-based separation of DNA molecules comprising several hundred or more pair bases, including plasmid DNA molecules. The gel is hydrophilic, chemically inert, and stable. The three-dimensional matrix of the agarose gel is brought about by non-covalent bonds formed between polysaccharide units. The composition of the matrix used in protein aging of LPMB is polyacrylamide gel electrophoresis. Page is undoubtedly one of the most widely used techniques to characterize complex proteins mixtures. It is a convenient, fast, and inexpensive method because they require only the order of micrograms quantities of protein. These buffer systems are used for most forms of DNA agarose gel electrophoresis, which commonly contain EDTA at pH 8 and Ti, or TBE at a concentration of approximately 50 millimolar with a pH 7.5 to 7.8. Ti is less expensive but not as stable as TBE. In addition, Ti gives better resolution of DNA bands, ensured electrophoretic separation, and is often used when subsequent DNA isolation is desired. On the other hand, for proteins, we use a detergent called SDS. SDS is a reducing agent that breaks disulfide bonds separating the protein into its subunits and also gives a net negative charge which allows them to migrate through the gel in direct relation to their size. Silencianol and bromophenol blue are the two common dyes used as loading buffers, and they run about the same speed as DNA fragments that are 5,000 base pairs and 300 base pairs respectively. In protein, the COMC blue staining allows detecting up to 0.2 to 0.6 micrograms of protein, and its quantitative linear, up to 15 to 20 micrograms. An example of a reference marker for DNA PMOL28 plasmid would be CR1 kilobase DNA marker made by CMO researchers. For Canis lupus RNA, the reference marker would be ladder of 9 RNA transcripts by Promega, and HN protein, and from HN protein would be broad range SDS page standards with 9 bands by Bio-Rad. The visualization of each sample would look like this: DNA PMOL28 plasmid, Canis lupus RNA, HN protein from LPMB4.
Methodology 1. The exact amount of agarose, concentration of 0.8%, 1.6%, and 2.5% was calculated, weighed, and dissolved together with Ti TBE buffer. The dissolution was carried out in a microwave. 2. Assemble electrophoresis chamber. 3. Once the agarose was cooled, gel red was added, mixed, and emptied into the electrophoresis chamber mold. 4. Register the order in which the samples are loaded into the gel. 5. Add the buffer in parafilm depending on the volume that is loaded with DNA and mix with the DNA sample and markers with the micropipette. 6. Place the mixed sample in the indicated well. 7. Run samples for 1 hour at 100 volts. 8. Visualize gel in transilluminator and document image.
Results. In the following figures can observe the 6 different electrophoreses. In the first and second figure can observe the 3 different agarose concentrations at 0.8%, 1.6%, and 2.5% that correspond at the pictures A, B, and C in buffer Ti at 1x and TBE at 1x, and were lining with the same sample in the well 4, 5, 6, and 7, and stains with hell red at 0.2x. That is very dangerous. In all figures, use the molecular weight marker fast DNA later because it's the most clearest in this size. Then, in the 6 different healths, we point the most representative problems that can see, with the purpose of identify and correct in the future practice. In the next figure can observe the problems that could present the next 3 healths. The number 1 represents the white tonality that is identified. Is due to silencianol dye in the charge buffer. Then, in number 2, can see the accumulation of dark banks, that is, the presence of RNA. In the number 3, observe an accumulation of sample, in wells that represent a protein interference. In number 4, observe the presence of degraded DNA. And in number 5, the band obtained by PCR is distorted, mainly due to an excess of sample. In the next figure, we can observe the problems that could present the next three TB healths. The number 1 represents the white tonality that is identified is due to hydrogenol dye in the charged buffer. Then, in number 2, can see the accumulation of dark banks, that is, the presence of RNA. In number 3, observe the accumulation of sample in wells that represents a protein interference. In number 4, observe the presence of degraded DNA.
Analysis and discussion. From the gels obtained, it can be observed that the sample shift is inversely proportional to the concentration of agarose. Because the agarose is not homogeneous, the concentration and choice of agarose used in the gel depends on the size of the DNA analyzed and on the subsequent procedures that will be provided. In this case, there was no reference to the size of the samples. However, the PCR sample was known and used. According to the established standard, it is stated that for 450 base pairs, it is convenient to use a gel with a percentage between 2 and 3%, from which it is interpreted that the quality of the agarose gel at 2.5% will be the most defined according to the small difference between the standard percentage and the percentage used. In a buffer of high ionic strength, the electrical conductance is very efficient and significant amount of the heat is generated. There are different categories of buffer systems, such as dissociation and non-dissociation, continuous and discontinuous. In this practice, the TAE and TBE shift buffer were used, referring to a continuous system. From the gels obtained, it is stated that the sliding gel that provides a better image quality is the TBE, where the bands are very defined. It can be seen in the wall 7 from the sample of PCR product. The loading buffer should be added to the DNA fragment that will undergo electrophoresis. This contains glycerol or sucrose to increase the density of DNA solutions. Otherwise, the samples would dissolve in the electrophoresis chamber. In the same way, it contains dyes that facilitate the observation of the samples in the gel. One of the main components of the loading buffer is red gel, which has a greater sensibility. It is considered that the loading buffer was not integrated correctly because it is not possible to appreciate the markers that indicate the mobility of the samples to know their speed. According to the above, it is observed that in gels, mainly in TAE buffer at 2.5%, the bands were much higher according to the standards. In this case, the gels obtained, the bands of the marker are appreciated in a differentiated way are those from the marker fast DNA ladder. This substance must be stored under the required conditions due to the risk of contamination. A sample of 450 base pairs was specifically in the PCR sample. In the case of the TAE buffer, gel A has a value of 0.4 kilobases, showing greater similarity to its real size than C or D gels, which has a difference of 0.1 kilobases with the real sample. In contrast, in the TBE buffer gels, B and C have a value of 0.4 kilobases, showing greater similarity to the real size than gel A, which has a difference of 0.1 with the real samples. Regard to the samples of the plasmid in the 6 gels, different bands can be seen. It is considered that at a moment in which plasmid DNA is extracted from bacteria, a purified product is obtained. However, the presence of different bands ensures that it is not pure. It is considered that in the 6 gels, the genomic DNA is contaminated with RNA because of the accumulation is formed in the lower part. According to the quantity and quality, it is stated that the gels were not loaded correctly. Given that the bands are not distinguished, it can be said that there was an excess load, mainly in wells 5 and 6, and the markers in wells 2 and 3 for TAE, wells 1 and 3 for TBE. It was observed that the pipetting technique was not correctly given the visualization that was obtained. However, the exact size of DNA was not known. Finally, it is stated that the shift time and voltage were adequate because for each centimeter of the mold of the electrophoresis chamber, 5 volts are required. In this case, the box has a measurement of 20 centimeters, giving a total of 100 volts required.
Conclusion. It is extremely important to have a good pipetting technique, to take precautions and the necessary measures as well as to follow the supplier's indications to obtain quality samples from the agarose gel electrophoresis. From the gels obtained, it can be observed that the sample's displacement is inversely proportional to the concentration of agarose. So the choice of Its percentage is based on the size of the DNA to be analyzed. As a shift buffer, it is established that the TBE presents greater stability by providing bands that are more defined than the TAE buffer. Red gel corresponds to an ultra-sensitive loading buffer. However, this was not integrated properly. The above is based on the fact that it is not possible to appreciate the markers that indicate the mobility of the samples that allow to know their speed and to carry out the monitoring of them. From the gels obtained, the bands of the marker that are appreciated in a differentiated way are those of the marker fast DNA ladder. This sample coming from PCR has good integrity when observed as a band defined in the gel with TBE buffer. Similarly, the quality of the plasmid DNA does not possess good integrity because it is possible to observe more than one defined band. Finally, the integrity of the genomic DNA is not appropriate when presenting RNA interference in all 6 gels. The running conditions, 1 volt per 1 hour, were adequate given the established standards.
Bibliography.